In 2017, something entered our solar system from the darkness between the stars and almost escaped before we noticed it. It carried no beacon, showed no clear tail, and gave astronomers only a few weeks to understand what they were seeing. Then its path changed by a tiny amount, as though an invisible hand had pushed it away from the sun. That small deviation transformed an astronomical discovery into one of the most argued over mysteries of the modern sky. Some called it an unusual comet, others imagined a fragment of a distant planet or even a machine built elsewhere. But the stranger truth is simpler. Nobody ever saw its shape directly. We saw only a moving point of light. The story began on October 19, 2017, at the Pan-STARRS Observatory on the Hawaiian island of Maui. Its survey telescope repeatedly photographs the sky, searching for objects that move against the fixed background of distant stars. Astronomer Robert Werrick noticed a faint speck shifting position between exposures. At first, it looked like another small asteroid, but when its earlier positions were recovered, the orbit refused to close into the familiar ellipse of a solar system object. Its path was hyperbolic, open, fast, and unbound. The sun could bend its course, but could not keep it. The object had entered from interstellar space, crossed the planetary system once, and was already returning to the dark. It received a new designation, 1I, the first confirmed member of an entirely new class of interstellar objects. Its Hawaiian name, Oumuamua, is commonly translated as a messenger from afar arriving first, an unexpectedly fitting description. By the time astronomers found it, Oumuamua had already swept around the sun and passed relatively near Earth. That delay mattered. The object was fading quickly, forcing observatories around the world into an urgent race for measurements. Major telescopes tracked its brightness, color, motion, and spectrum, gathering every photon before it became too faint to follow. The result did not produce a photograph. Even through powerful instruments, Oumuamua remained an unresolved dot against the stars. Yet that dot brightened and dimmed dramatically, repeating as the object turned and presented different surfaces toward Earth. Early interpretations suggested something extraordinarily stretched, perhaps a cigar-shaped body several times longer than it was wide. Later modeling showed another possibility, a broad, flattened disk, more like a tumbling disk or thin, rocky pancake. The honest image is therefore not a cigar or a disk, but uncertainty rotating through a narrow beam of evidence. Its changing light also suggested chaotic tumbling, rather than the steady spin expected from a calm, undisturbed body. That motion may record a violent past, a collision, tidal disruption, or ejection from a planetary system around another star. Its surface appeared dark and moderately reddish, resembling material altered by radiation during a long journey through interstellar space.
So far, the mystery was remarkable but still natural, an ancient fragment, oddly shaped and thrown between the stars. Then, precision measurements revealed that gravity alone did not perfectly describe the object's outward path after its solar encounter. Oumuamua was accelerating away from the sun by a tiny additional amount, small but statistically difficult to dismiss. Comets often receive such pushes when sunlight heats their ice and escaping gas acts like a weak natural rocket. Normally, that process creates a glowing coma, a trail of dust or detectable gases surrounding the comet's nucleus. But telescopes found no obvious coma and no familiar tail. The expected signs of vigorous comet activity were missing. This contradiction became the center of the puzzle, a comet-like acceleration without the visible performance of an ordinary comet. One explanation is that Oumuamua released gas too faint, too clean, or too unusual for the available telescopes to detect. The object was small, distant, rapidly fading, and observed only briefly, so a subtle jet could have escaped detection. A later model proposed hydrogen molecules trapped inside radiation-processed water ice during the object's cold interstellar journey. As Oumuamua warmed near the Sun, that hidden hydrogen could have escaped without carrying much visible dust. In that scenario, the visitor was not alien technology, but a damaged icy planetesimal behaving in an unfamiliar way. Other researchers proposed more exotic natural bodies, perhaps a fragment rich in nitrogen ice, perhaps torn from the surface of an exoplanet. Another idea imagined an incredibly porous aggregate, less like a solid rock and more like a fragile cosmic dust structure. Collision models suggested a stretched shard, created when small planetary building blocks smashed together under unusual conditions. Each explanation can reproduce parts of the evidence. Each also requires assumptions that remain difficult to test after the object's departure. That is the danger of a visitor observed too late. Many stories can fit the same small collection of measurements. Then came the most controversial possibility, one that escaped scientific journals and spread rapidly through headlines around the world. Could sunlight itself have pushed Oumuamua, not through escaping gas, but by pressing against an unusually thin surface? Radiation pressure is real. Photons carry momentum, and reflective sails can use that tiny pressure to move through space. Researchers calculated that a sheet with an extreme area-to-mass ratio could, in principle, match the measured extra acceleration. That opened the door to the light sail hypothesis. Perhaps Oumuamua was artificial debris or a probe from another civilization. But a mathematical possibility is not the same as evidence. No image revealed panels, machinery, lights, or controlled movement. Radio telescopes listened across multiple frequencies for narrow artificial transmissions. They found no convincing signal coming from the object. Its trajectory also showed no clear maneuver toward Earth, no braking, and no behavior proving intention or intelligence. Most researchers therefore favor natural explanations, while acknowledging that the available data cannot identify one model with complete certainty. The alien idea survives because it occupies the space between what was observed and what can no longer be checked. Oumuamua is now far beyond the reach of present telescopes, dimming as it continues toward interstellar space. We cannot turn a camera toward it tomorrow, sample its surface, or repeat the encounter under better conditions. No spacecraft was waiting. By the time humanity understood its importance, the visitor had already passed the best interception window. That failure changed astronomy. Survey teams now know that objects from other star systems can cross our neighborhood unnoticed. In 2019, Comet Borisov became the second confirmed interstellar visitor, displaying the clear coma and tail Oumuamua lacked. A third confirmed interstellar object, 3I Atlas, later proved that these crossings are rare discoveries, not impossible events. Yet neither visitor erased the first mystery. Instead, they showed how different objects from distant planetary systems can be. Future surveys may detect the next one earlier, while it is still approaching and bright enough for detailed study. A rapid response spacecraft might someday launch towards such a target, photographing a surface formed around another star. Until then, every portrait of Oumuamua remains an artist's reconstruction built around brightness, motion, and educated uncertainty. Perhaps it was a comet unlike any we had seen, a planetary fragment, or a fragile relic shaped by deep time. But because humanity noticed it only as it was leaving, the messenger carried its final answer back into the dark.